Okay, let's talk about some of the more dynamic properties of suspension, specifically related to this type of suspension, which is a double wishbone, double A-arm, 4-bar linkage type suspension, whatever you want to call it. And the first thing I want to talk about is, let's talk about the track width. So we went over track width earlier, but it's important to note that your track width can change some. The track width is the distance between the contact patch on one side to the center of the contact patch on the other. And you'll notice that as the suspension compresses and then rebounds, it actually changes quite a bit. So it goes from about right here to a little bit wider, and then when it rebounds, it's actually quite a bit narrower. And that has to do with how long your A-arms or your control arms are. The other thing we should talk about is your instant center. So if I drew a line from here to here, or parallel to these control arms, and we look at where they intersect, this is actually the point at which your tire is going to be rotating when the suspension is compressed or rebounding. But it actually changes quite a bit. But the farther away this is from the tire, the less camber gain you're going to have as the suspension moves. So that's something to take into consideration. So if your control arms were exactly parallel, like this, you would actually have zero camber gain as the suspension goes up and down. And this is something, again, that changes. So let me erase those two lines. And I'm going to compress it, and let's see where the instant center is here. So now the instant center is down lower and maybe a little bit closer too. So you don't want the instant center to change a whole lot. And you don't want it to be too high or too low, typically. And again, I'm sure there's books about instant centers and where they should be. All right, the other thing we should talk about is the roll center, and that's actually the point at which your chassis is going to rotate about. And again, this is something that's going to change. So the roll center is kind of a step beyond where the instant center is, but we need it for both sides. So I'm going to draw the instant center. So it's right here. And then I'm going to project from the instant center to the center of the contact patch. And we can do that on both sides. But this is actually symmetrical. So if we did it on the other side, the intersection would be right here. And this is actually where the roll center is. And this is the point, the virtual kind of point at which the body is going to be rotating about. And again, as a rule of thumb, you don't want this to be probably too low, and you definitely don't want it to be too high. You definitely don't want it to be above the CG. But again, read up on that if that's something you want to know more about. And this is again a point that can change quite a bit as the suspension moves around. So right now it's just below this subframe. And if we play the animation and put it at full compression, let me erase this. Now let's see where it is here. So I'm going to project down my instant center right there. Here's my intersection. So it doesn't look like it moved a whole lot. So that's good. All right, let's talk about steering. And steering is very important. How you set up your geometry, especially for a 4-bar or a double wishbone suspension. And the first thing we should talk about is bump steer. And bump steer is this negative property of when your suspension moves, the steering or the toe angle changes. So this suspension actually has a little bit of bump steer, and let's go into a top view and we'll look at it. Let me hide this. And so right now the tires are pointing straight ahead, so there's no toe in, no steering angle. As the suspension compresses, you can see maybe a little bit, there's not a lot of bump steer and compression, that the tires are now pointing in a little bit. So it's got a little bit of a toe angle. And when it goes into rebound, now it has a toe out condition. And generally that's bad. You don't want any bump steer, or you want to minimize it. And again, this isn't a lot for this vehicle, especially since it's replicating an old jalopy race car. So it's not really supposed to be a high performance, well sorted out vehicle. But that's something to be aware of. And the best way I have found to design for minimal bump steer or double wishbone suspension is, well, I'll show you that now. So this is the back of the front suspension here. And if we draw a line, let's draw our 4-bar linkage here. So there's our lower control arm. Here's our upper control arm. And we can draw lines between them. So that would be our upright, and this is where it attaches to the subframe or the chassis. And if you want to minimize or eliminate bump steer, you need to have your steering linkage. Here's my steering linkage right here. You need to have it the same angle and the same length as either your lower control arm or your upper control arm. But you do have other options because you can actually move that up proportionally. So, and that's kind of what I did here. So you can also have it, for example, 50% up, so halfway up this line, and then connected to halfway up this line. So like that. And that's basically what I did. But you want it to be the same angle, and you could also have it, 25% up, or 1/4 of the way up, 3/4 of the way up. And you could even, if you wanted to, you could probably project it down this way. So you could have it 10% longer than the length of this line, and so forth. The other thing we want to talk about is Ackerman. And Ackerman is the idea, let me erase this. Ackerman is the idea that the inside tire has to turn a sharper corner than the outside tire. Let me turn on the rear suspension here. So there's my rear suspension. So I'm going to go to where this is turning. So here we are at full lock. And if we want to know the radius this is turning, we can draw a line along the rear axle here. And then I'm going to start with the outside tire, and I'm going to try and draw it perpendicular to the tire best I can. And then Ackerman is the idea that this tire has to turn at a slightly larger angle to hit the same center. So this would be the center of the circle this vehicle would be turning around. And you can tell that this angle is greater than the angle this one's turning. So these eventually will intersect somewhere out this way. So you can tell this one's the greater angle. And the best way, I think, to do Ackerman, and I have some Ackerman here, obviously, is instead of having your steering linkages in line from a top view, so this is a top view, in line with the control arms, you actually want to shift them over this way some, towards the center of the vehicle. And that's going to give you some Ackerman. And so so it's this angle that this is at. So if this was just straight back, so kind of the line to this pivot point of the control arm to this pivot point of the steering link, if that was 0, or along this line, then there would be 0 Ackerman. And because mine's along this line, it has some Ackerman. If it was along this line, it would be reverse Ackerman, and I'd recommend against that. Likewise, you could project, if you want your steering linkage to be in the front of your suspension, it would also need to be along this line. So in that case, it would be shifted this way. So those are just some design principles. There's, of course, a myriad of other things you could research, but I think this will kind of keep you in the safe zone of what we're going to be doing. Blender, of course, will take all this into account as far as, having good Ackerman steering will help you. Having good camber angles will help you a little bit, especially visually. And, minimizing bump steer will make the vehicle a lot easier to control. It will be a lot more predictable. And having your instant centers and stuff like that, which can affect things like jacking forces, that'll make your vehicle handle more realistically also. But, Blender, at least for this course, we're not going to have any kind of a tire model. So there's not going to be, tire models can be very complex, and Blender does not have a tire model. So some of these things aren't going to have as big of an effect as in the real world, but they do have some effect.